In the previous video, we worked 5 problems involving applications where we have to use linear equations in one variable or rational equations to solve the problem. I wanted to do another video where we work 5 more problems, the exact same type, but just different problems, just so that maybe you went through that first video and you found it difficult, you got a lot of practice, so now you can come to this video and try again, which it should be a little bit easier this time. All right, Ebony bought a 5-year treasury note that paid the equivalent of 2.8% simple interest. She invested $5,000 more in a 10-year bond, earning 3.6% than she did in the treasury note. If the total amount of interest from these investments was $5,300, determine the amount of principal for each investment. So we're dealing with simple interest here, where the interest is principal times rate times time. Okay, I'm not going to go into as much detail in this video about the meaning of all these equations, like the meaning of this. We talked about that in the textbook video where we went through the textbook, and in the previous example problem video. So we have what? Determine the amount of principal for each investment. So the treasury note and a bond. Okay, so we'll call T as the treasury note, the amount she invested in the treasury note, and B the amount she invested in the bond. Okay, so the total amount of interest from these investments, that total amount of interest, the interest. Okay, we could have interest from the treasury note plus interest from the bond is equal to $5,300. Okay. What else? She invested $5,000 more in the bond than she did in the treasury note. Okay, so she invested in the bond, she invested $5,000 more than she did in the treasury note, right? So the bond amount she invested, take the treasury note, add $5,000 to it. Okay, now in this formula, the P is the initial investment. Let's write this out here. We've got this IT is what? So we've got T times the rate of the treasury note, 0.028, times the time of that investment, 5 years. Okay. IB, the amount she invested in the bond, initially invested, times the rate of the bond, times how long was the bond? 10 years. That's equal to 5,300. Okay. So 0.028 times 5.14. Okay, 0.036 times 10 is 0.36b. Now we can substitute this b here. So 0.14t plus 0.36 t plus 5,000 okay, so 0.14t plus 0.36t plus times 0.36, 1,800. Okay, 0.14 plus 0.36, we can combine these two like terms. 0.50t is equal to 5,300 minus 1,800. $3,500. Now we can divide both sides by 0.5. T is equal to 7,000. This is $7,000. Okay, so now what is B? B is just 7,000 plus 5,000. T plus 5,000. That's $12,000. So there we go. Antifreeze is a compound added to water to reduce the freezing point of a mixture. In extreme cold, one car manufacturer recommends that a mixture of 65% antifreeze be used. How much 50% antifreeze solution should be drained from a 4-gallon tank and replaced with pure antifreeze to produce a 65% antifreeze mixture? Okay, so we're trying to create a 65% antifreeze mixture in this 4-gallon tank. So you really want to make sure you understand the problem. We've got this 4-gallon tank that's currently a 50% antifreeze solution. We're going to drain a certain amount of that out, that 50% solution out, and replace it with pure antifreeze. And we want to create a 65% solution. So how much of this, let's call this X, how much of that 50% antifreeze solution do we need to take out that we're going to replace with pure antifreeze to create the 65%? Okay, so we want to kind of track the antifreeze, right? So like the amount of antifreeze. So we start with what? Let's take this X away here, because I might want to change that to an A. Based on what we did in the previous video, this kind of problem, I'm assuming that it's like this 50% is the ratio of antifreeze to water, like antifreeze by volume to water by volume. And they're giving us gallons here. So initially, they give us the amount of gallons, this 4-gallon tank. I'm assuming it's like filled. It's filled. So we've got what? It's a 50% antifreeze solution. So A initial, A naught, right? A initial, we'll call it like A at times 0, I guess you could say. Or I don't know I'm not sure what that naught means. A0. That's the amount of antifreeze in gallons. Divided by 4 is equal to 0.5. Okay, if we multiply both sides of this equation by 4, we get 2 gallons of antifreeze. That's what we're starting with. Now we can see so we're going to add pure antifreeze. So we'll call that just A. We'll have A0, A, and A final, and A is like the pure antifreeze. I know this is probably not the best variables, but you get the idea. So A plus, so the pure antifreeze plus what? Plus no. Okay, wait. We start with 2 gallons of antifreeze. That's how much antifreeze we have. We're going to drain some out and replace it with pure antifreeze. So let me just make sure we have enough room here. We're starting with, we start with 2 gallons worth of antifreeze in a 4-gallon tank. We're going to remove some of this. So the antifreeze solution we're going to remove, the amount, let's call that X, that 50% solution, okay? That's how much we're going to remove. So if we want, how much antifreeze are we going to remove? Not just solution. We're going to remove A naught minus, and what is it? X times 0.5, so 0.5x. Right? We're tracking antifreeze here. We start with 2 gallons worth of antifreeze in our 4-gallon tank. We're going to remove a certain volume of that 50% antifreeze solution. So 50% of that volume that we remove is antifreeze we're taking out. Right? But then we're going to replace that with a pure antifreeze. We'll call that A. A is pure antifreeze. So this might get a little confusing. X is gallons of 50% solution removed. A is gallons of pure antifreeze added. A naught is gallons of starting antifreeze. Okay? And then A final is in the 65% solution. So A final is final amount of antifreeze. Okay? We're talking gallons of antifreeze, not solution. All right? But we know, what do we know? We know that AF divided by 4 is 0.65. So if we multiply both sides times 4, the entire equation, AF is equal to 4 times 0.65, 2.6 gallons of antifreeze. Okay, we know A naught, so let's do this. 2 minus 0.5 x plus A is equal to 2.6. So what is A? Gallons of pure antifreeze added. So we need another relation here. I mean, let's simplify this equation. So let's add 0.5x to both sides. So we have 0.5x plus 2.6, and I'm flipping the equation. Okay, 0.5x plus 2.6 is equal to A plus 2. So if we subtract 2.6 from both sides, we get 2 minus 2.6 is minus 0.6. So we need another equation. What can we say? Well, is this X and A related? Yeah, the gallons of 50% solution removed is equal to the gallons of pure antifreeze added. X equals A. Right? That's the idea. You're draining a certain amount and replacing it with pure antifreeze. So X equals A. 0.5x is equal to X minus 0.6. Let's subtract X from both sides. You get minus 0.5x is equal to minus 0.6. Divide both sides by minus 0.5. X is equal to 1.2 gallons. Peggy competes in a biathlon by running and bicycling around a large hoop through a city. She runs the loop 1 time and bicycles the loop 5 times. She can run 8 miles an hour and she can ride 16 miles an hour. If the total time it takes her to complete the race is 1 hour and 45 minutes, determine the distance of the loop. Okay, so let's create our variables here. What is the rate that she runs the loop? Okay, well, no. All right, the rate that she runs, not the loop, just runs, is 8 miles per hour. The rate that she bicycles is 16 miles per hour. Okay, if the total time it takes her to complete the race is 1 hour and 45 minutes, determine the distance of the loop. Okay, so we're going to be using this D is equal to RT. So she runs the loop 1 time. So what is the distance she travels when she runs the loop 1 time? It's 8 times the time to run the loop. Right? So let's say, like, you have to define your variables correctly here. So the TR is time to run 1 loop. TB is time to bike 1 loop. Okay, so 8 times the time to run 1 loop, and she only runs it 1 time. Okay, now what about, that's the total distance that's the distance there. Or wait, hold on. Let's do it. We know that, Okay, let's relate to this 1 hour and 45 minutes. 1 hour and 45 minutes in decimal form is 1.75 hours, right? 45 minutes is 3/4 of an hour. So the time for her to run a loop plus 5 times the time for her to bike a loop, right? Because she ran the loop once and biked it 5 times, is equal to 1.75. Okay. So now what is time? It's rate divided by distance. Okay. But what's going to allow us to solve the problem is that the distance of the loop has no relation to biking or running. So the time to run, the TR, right? Remember, this TR and TB is defined in terms of one loop. So what is TR? Distance divided by rate. We'll call this is the distance of loop. Okay, D divided by 8, right? Because T is equal to R, or no, D divided by R. Distance divided by rate. Plus 5. Now we're still just talking about one loop here. This 5 takes account of all 5 of the loops, but we're talking about one loop with this TB, right? Think about how we define this. So TB is just D again, one loop, divided by 16. There we go. Now let's solve for D. This is a linear equation in one variable. So, well, we can do this. 1.75 is what? 1 3/4 is equal to 4 7/4. Okay, so we can multiply this entire equation to get rid of these fractions by, it looks like 16. So we get 2D plus 5D is equal to 7 times 4 is 28. 2D plus 5D is 7D is equal to 28. D is equal to 4. This is in miles, right? Well, we kept all of our units consistent. D is 4 miles. Brad and Angelina can mow their yard together with 2 lawnmowers in 30 minutes. When Brad works alone, it takes him 50 minutes. How long would it take Angelina to mow the lawn by herself? So I'm assuming we're talking about Brad Pitt and Angelina Jolie. And so what you want to do here is try and get inside the heads of Brad and Angelina. How would they be interacting with each other about arguing about mowing the lawn? That's a joke. I'm joking. Okay, so when Brad works alone, we'll say that we've got RB. The rate that Brad works is what? It takes him 50 minutes. So his rate is 1 lawn in 50 minutes. You could put the opposite, like 50 minutes per lawn, but I guess when you think of a rate, it's like you put the time in the denominator, but you could do it however you want. Okay, so the rate of Angelina is, we don't know that. Okay, but together, if you add the rates, and I explained in the previous video how you can think about the idea of adding rates in this scenario, RB plus RA is equal to 1 lawn in 30 minutes. How long would it take Angelina to mow the lawn by herself? Well, we know that RB plus RA is equal to 1 over 30. We know that RB is equal to 1 over 50. So 1 over 50 plus RA is equal to 1 over 30. Subtract 1 over 50 on both sides. Okay. And we've got what? This is, so least common denominator would be 150. 30 times 5 is 150. 50 times 3 is 150. So, okay, that's Angelina's rate. So what is this? Is 2 lawns in 150 minutes. Okay, so how long would it take her to do 1 yard? Well, okay, we need to simplify this. It's all right. We can divide 2. So 1 lawn would take Angelina 75 minutes. That's your answer. Right? To estimate the number of bass in a lake, a biologist catches and tags 24 bass. Several weeks later, the biologist catches a new sample of 40 bass and finds that 4 are tagged. How many bass are in the lake? Right? This is an estimate. This is the way you can estimate it. Estimate the amount of bass in the lake. And you're going to use proportions. So you'll say, okay, let's say N is the number of bass in the lake. Let's say NB. NB is the number of bass in the lake. So she catches and tags 24 bass. So the idea is you've got NB divided by 24 is the ratio. Like once she catches, or she or he, is it a she or he? It didn't tell us. Let's say a she. She catches 24 bass, puts them back in. So now the ratio of total bass in the lake to tagged bass is NB divided by 24. And that's so the idea is if she catches another sample of 40 bass completely because when several weeks later, she comes back and all the bass are like spread out evenly. That's the idea, right? She didn't come back 5 minutes later, that same spot, and catch the bass. Several weeks later, they're like randomly distributed now. And so she just catches a random sample of 40 bass. The idea is like this ratio is K. Okay, so whenever she's going to find, well, we can just do this. We don't have to say K. Well, let me say K just to illustrate this for you. So that's K. That's that ratio. So when she catches a random sample of 40 bass and finds 4 tagged, it's going to be that same ratio. You see? Now this is an estimate, but not a bad estimate, depending on the total numbers. So we can multiply. Let's cross multiply. 24 times 40. So 4 times NB is equal to 40 times 24. Okay, 40 times 24, 960. 4 NB is equal to 960. Divide both sides by 4. $240. So that's the total number of bass in the lake. That's an estimate for the total number of bass in the lake.